Imagine waking up tomorrow and discovering that the solar system has been scrambled like a cosmic puzzle. Mars now orbits where Mercury once did. Neptune circles close to the Sun. Jupiter drifts far out beyond Pluto. Every planet has traded places as if some giant hand reached in and rearranged the orbits overnight. It sounds like pure science fiction, but thinking through what would happen reveals just how delicately balanced our solar system really is. Right now each planet follows a path shaped by billions of years of gravity. The Sun's pull, the mutual tugs of the planets, and the leftover motion from their birth create a system that, while dynamic, is remarkably stable. Move just one planet significantly and the careful gravitational choreography starts to unravel. Swap all their orbits and you get a cascade of chaos. Start with tiny Mercury. If we dropped it into Neptune's icy orbit, the Sun's warmth would be a faint glimmer. Mercury's thin exosphere, already barely an atmosphere, would freeze and collapse. Its surface, which now sizzles during the day, would plunge to hundreds of degrees below zero. Meanwhile Neptune, suddenly only 58 million kilometers from the Sun, would boil. Its thick hydrogen-helium atmosphere would puff outward and probably escape into space. Methane clouds that give it a blue hue would vanish. The planet might temporarily develop a brilliant comet-like tail as gases stream away. Any moons it carries inward would be ripped apart by the Sun's gravity or collide with the inner planets. Put Venus out where Uranus lives and its runaway greenhouse effect would eventually calm. With sunlight 19 times weaker, its surface would cool enough for carbon dioxide to condense, maybe forming dry ice glaciers. Over millions of years Venus could even develop a stable atmosphere and frozen seas. Bring Uranus inward to Venus's current orbit and you create a mini Jupiter glowing like a second sun. Its frigid atmosphere would heat and expand, producing hurricane winds and continuous lightning. Moons such as Miranda and Titania would face fierce solar radiation and tidal stresses, likely melting and reshaping their icy crusts. Where would Earth end up in this interplanetary shuffle? Suppose it trades with Saturn and drifts out to 1 billion kilometers from the Sun. Sunlight there is only 1% of what we receive now. Within weeks our oceans would begin to freeze. In a few years a thick shell of ice would cover the planet. Deep below, geothermal heat might keep pockets of liquid water alive, but the surface would resemble Europa, an icy desert under a dim sun. If instead Earth were dropped into Mercury's orbit, we'd face the opposite fate. Average temperatures would soar well above the boiling point of water. Oceans would evaporate, the atmosphere would thicken with steam, and life as we know it would be impossible. Now imagine Jupiter plunging inward to Mars's orbit or even closer. Its immense gravity, more than twice the mass of all the other planets combined, would destabilize everything. It could fling Mars into the Sun, hurl asteroids toward Earth, or distort the orbits of Mercury and Venus until collisions became inevitable. If Jupiter moved outward instead, the solar system would lose its gravitational shield. Today Jupiter's gravity deflects many comets and asteroids that might otherwise strike Earth. Without it in place, the inner planets would suffer far more impacts, reshaping their surfaces and climates. Saturn, with its elegant rings, would also behave dramatically in a new orbit. Shift it inward toward the Sun and the delicate icy rings would sublimate, perhaps collapsing into a broad equatorial disk of dust. Push it far outward and the rings might freeze even harder but grow unstable under the pull of distant Neptune or passing stars. Changing every planet's orbit at once sets off a gravitational chain reaction. Planets passing close to one another would exchange momentum, sending some spiraling inward and others outward. Resonances that currently keep bodies like Pluto in safe, repeating paths would break. Within a few million years the new system might eject several planets entirely, turning them into wandering, rogue planets, drifting between the stars. Moons would fare even worse. Each planet's hill sphere, the region where its gravity dominates, depends on its distance from the Sun. Move the planet and that sphere shrinks or grows. Many moons would be stripped away and either captured by other planets, smashed into their parent worlds, or flung into interstellar space. Asteroid belts and comet reservoirs would be stirred like a hornet's nest. Showers of debris would rain through the inner system for ages, pummeling any planet lucky enough to remain habitable. From Earth's perspective, the night sky would transform. If we lived on a world now orbiting near Jupiter's old path, our sun would appear small and pale, and neighboring planets could loom huge and bright. From the frozen surface you might see Venus shining like a tiny distant star while Neptune glows faintly nearby. If instead Earth sat close to the Sun, the other planets would race across the sky at startling speeds. Gigantic Jupiter might dominate the daylight for weeks before swinging away. In reality, such a shuffle is nearly impossible without an outside force, a passing star, a massive rogue planet, or some deliberate intervention by an unimaginably advanced civilization. But scientists do know that planetary migration happens in young systems. Gas giants can drift inward or outward while disks of gas and rock are still forming. Observing distant exoplanets that orbit scorchingly close to their stars gives us clues that our own solar system may have experienced smaller migrations early on. Thinking about a grand planetary swap reminds us how finely tuned our current arrangement is. Earth occupies a Goldilocks orbit where liquid water and a stable climate are possible. Jupiter's position helps protect us from frequent asteroid bombardment. Mars, Venus, and the outer giants each play a role in the balance. If the planets ever truly changed places, the solar system would become a shooting gallery of worlds and debris. Some planets would freeze, others would boil, and gravitational chaos could last billions of years before a new equilibrium emerged, if it ever did. So the next time you look up at the quiet, predictable night sky, remember, its order is not guaranteed by any cosmic rule. We live in a fragile masterpiece of gravitational harmony, and even the slightest reshuffling would rewrite the story of every world we know.